Okay, so now let's move on to solve the some selected problems for the chapter 20 is the geometry of the volume 1. So the question I pick, it doesn't mean it's very difficult. Sometimes I also pick some problems, the results are very important. The problem may not be difficult. So let's move on with this one. So congruent circles P and Q. So we know the RP equals to RQ, right? So let's see, equals R. So P and Q are tangents, so the PA also tangent to the O. Okay, so this is 90 degrees. Then so we know the AP is 15. We want to solve the AP is 15. We want to solve the R. So we can connect it to the PQ, right? So here is R, here is R, and we can extend it. Here is R, right? So the touching point is T. So based on the power point of the P, right? So we know the AP square is equal to the PT times the PR, right? So the 15 square is equal to the PT is R and the PR is 3R. So then we know the R square is equal to the 15 times the 5, right? So R is equal to the 5 root 3. Okay, so the power point is very, very important, okay, on the circle. 351, okay, so 351 is we have a trapezoid, is an isosceles trapezoid. Okay, so isosceles trapezoid is a symmetric, right? So A, B, C, D. Then we have AB parallel to BC. We have AB equals to 8, and this one equals to 4. And also we know the two diagonals are perpendicular to each other, right? So find the area. Okay, so what we can see is this triangle, right? The COD is similar to triangle the AOB, right? So the ratio is 2, so this is 2A, this is the A. We can parameterize all these sides, right? And once we parameterize this side, then we try to find the area of the ABCD, right? So in this case, if we can solve the A, right, and now we can solve the ABCD, right? So because you can see here is the right angle, right? So and also by symmetry, so this is the isosceles right triangles. So A is equal to 4 over root 2, right? So now the S of the ABCD is equal to half of the AC two diagonals, right? Times BD is equal to half of the 3A. 3A is 9A square is 9 over 2, then times the 16 over 2, right? So now this one is 4, so the answer is 36. Okay. So 353. So a band is wrapped tightly around the two poles, right? So we have two circles. Okay. Then we have the circle, let's call it P, and it's Q, right? So the whose centers are 6 feet apart, right? So if we connect the PQ, we know the PQ is 6 feet, right? And the radius of the pulley is 1 and 4 and 1, right? So we can have this one is 4, this one is 1, so in the middle is 1, right? PQ, let's see, is A and B. Okay, and then we have a band is wrapped tightly, right? So a band is wrapped tightly around it. So it's both tangent here, right? So yeah, so we want to find the length of this band, right? So this is the band, right? This is the band. So basically, this one you can see it's C, A, D, and E and F. Then we can have this one as a perpendicular. Okay, so the total band is the CD arc, right? That's this one, plus the FE arc. That's this one, right? Then plus 2 of the CE, right? The 2 tangent lines. So now let's solve the CE first. Okay, CE is easy to solve. So we can do a perpendicular line here. So here is the 6, right? This is the 1, so this is the 1, so this is the 3, right? So we can solve the CE square is equal to the 6 square minus 3 square is equal to the 36 minus 9. It is the 27, right? It's 3 root 3. So now we solve the CE. So this part is equal to 6 root 3, right? Now we need to solve the CD arc and the EF arc, right? In order to solve the CD arc and the EF arc, we'd better know its angle, right? Because once we know the angle, we can solve it. Okay. So so now let's see what is the angle. Okay, now we can try to solve this angle. Because this is the 3, right? And this is the 6. So that's why we know this angle is 60 degrees. So this angle is 60 degrees, right? So that means the CD arc is equal to the 240 over 360, right? That's 2/3 of the arc, and then times pi, 2 pi of times 4, right? Because that's has radius of 4. And the FE arc is this way is 120 degree, right? Is 120 over 360, then 2 pi times 1. So this one equals the 8 pi times the 3 over 2. This one is 2 pi times the 1 over 3, right? So now you can see this is the 16 over 3 pi. This one is the 2 pi over 3. Okay, 16 pi over 3 and the 2 pi over 3. Now you can add them together. It becomes 18 pi over 3. So this part is the 6 pi. Then this part is 6 root 3. So it's 6 pi plus 6 root 3. Okay, so question 356. So we have a pentagon ABCDE. The perpendicular bisector of the AB passing through the vertex D. So we have AB, and there is a perpendicular line bisector. It's passing through the D, ABCDE. Then point P is on the AB. The pentagon is symmetric with respect to the passing through AB, and point P on the AB. Okay, point P is on the AB. Then with respect to the DB. Okay, so the the pentagon is symmetric with the DP, right? And BC is parallel to AE. Okay, so let's draw a ABCD CDE. Okay, so the pentagon is symmetry to DP, right? Okay, that means we need to modify it a little bit, right? So the pentagon is symmetry to DP means this is the ABCDE. So the E and the C are symmetry, right? The A and the B are symmetry. This is the perpendicular bisector. Then you can see the BC also parallel to AE, right? So in order to have symmetry, we need this angle equal this angle, and they can be parallel, right? If they parallel means this must be a right angle. Okay, so now we when we dig into the shape by symmetry and the parallel, we know this is 90 degrees. And this is also 90 degrees. So we know we have the AE parallel to PD and parallel to BC. Then the BC is 4, right? By symmetry, this is also 4. And the AB is 8, right? And the DP is 7. So we can try to extend this one a little bit, right? Because it's easy to... What's the pentagon area, right? It's easy to solve in the triangles. Okay, let's see. This point is G, and this point is H. Okay, so now we have the similar triangles, right? So we know the 4 over the 7 minus 4 is equal to the AG over 8. Then we can solve the AG is equal to the 32 over 3, right? So this is the 32 over 3, and this is 32 over 3. So we know the triangle, the DGH is equal to the 16 plus the 64 over 3 is the side, right? Is half times the height is 7. So this one is the 7 over 2 times the 3 is the 48 plus 64, right? 48 plus 64 is 2 is 112. 112, right? So it's 3, then it's the 56 times 7. Okay, and now we can also easily to solve the triangle AGE, right? AGE is half of the 32 over 3 times the 4 is equal to the 64 over 3. Okay, so now the pentagon ABCDE is equal to the triangle DGH minus 2 of the triangle AGE. So then you get you put all those numbers in, right? And you can solve the result is equal to the 88. Okay, so we want to solve this question 363. So we have a rectangle of the paper, okay, and the width of the paper is the PQRS. Then the width of the paper is 8, and this one is folded, right? So we fold this one to make it touch this one. So that's here, right? So here is the B and the C and the D. Okay, so we know that the BC is equals 5, right? So by symmetry, this one equals 5, right? So this one equals 3. So we know this equals 4, right? Okay, so the goal is, what is the BD? Okay, so we know this angle is alpha, and this angle will be alpha. This angle is 90 minus alpha. This angle is 90 minus alpha, right? So this angle will be the 2 alpha. Okay, so we know the BD is equal to the BS over sine alpha is equal to the 5 over the sine alpha, right? So if we solve the alpha, sine alpha, we can solve the problem. So, but we know the sine 2 alpha, right, is within the 3, 4, 5 triangles. So it's 4 over 5, right? So this one is equal to the maybe cosine alpha is easy. Okay, cosine 2 alpha is 3 over 5. So this one is equal to the 1 minus 2 of the sine square alpha, right? So now we can solve the 2 sine square of the alpha equal to the 2 over 5. So we can see the sine alpha is 1 over root 5. Okay, if sine alpha is 1 over root 5, this one is 5 over 1 over root 5 is 5 root 5. Okay, that's 364. So in a triangle with a right triangle with side AB and hypotenuse C, okay, with the A and the B with the hypotenuse of C, attitude draw to the is X. Okay, so this is a right triangle, right? So we know by 2 ways to calculate the area, right? So 2 of S triangle ABC, ABC is equals to the A times B, also equals to the root A square plus B square times X, right? So then you can see the 1 over X is equal to the AB and the root A square plus B square. Then you square it. It's you can get is the 1 over A square plus 1 over B square. Okay, this result is pretty important. Okay. In a 5 by 12 rectangle, okay, 368. So in a 5 by 12 rectangle, okay. So let's do A, B, C, D. And it's a 5 by 12 rectangle. One of the diagonal is drawn. Okay, then we draw a diagonal. And then the circles are inscribed, right? So the inscribed is the intersection of the angle bisector. Okay, so we have one angle bisector here. We have a second angle bisector here. Okay, so I call this one is I1. This one is I2. So we want to calculate the distance between I1 and I2, right? So you can see the triangle ACD and the triangle ACB are totally congruent. Okay, that means all the corresponding lines, like the DI1, AI1, DI1 is equal to BI1, AI1 is equal to CI2. So all the corresponding sides are also equal. Okay, and also we have the radius must be the same, right? So So we must have this is the radius, right? Like this is the radius. Okay, so it means if the let's say the radius is x, right? So we have x, right? Here is the x. So here is 5 minus x, and we also have the x and the x, right? Here is x, here is 5 minus x. So this is also because this triangle, right, is congruent to this triangle. See, 5 minus x and 5 minus x, and we also know this the AC is equal to the 13, right? Because the triangle ADC is a 5, 12, 13 triangles. Okay. So if we want to solve the I1 I2, right? Okay. The I1 I2, we want to solve the I1 I2. So if we can solve the x, right? And if we also can solve this one, because 5 minus x, right? This one AO is half of the 13, right? So 2 over 13, right? So once we solve the x, and we can solve this problem. Okay. So now let's see how we can solve the x. Okay. By solving the x, you know that x times the s is equal to the triangle ACD, where s is half of the perimeter. So the ACD is half of the 5 times 12, right? And this little s is half of the 5 plus 13 plus 12 is equal to is 15. Okay, so now you can solve the x is equal to the 5 times 6 over 15 is 2. So if x is 2, right? So this one is 2, 5 minus x is 3, so 13 over 2 minus the 6 over 2 is 7 over 2. So now we can see the I10 is equal to it's the 2 square plus the 49 over 4, right? Is equal to the 16 plus the 49 over 4 is to root 65 over 2. Now this one is half of the I1 I2, right? So the I1 I2 is 2 times the root 65 over 2 is equal to root 65. Problem is the segment. We have a circumcircle. Then we inside a triangle ABC is inscribed in that. Then we know the this line is perpendicular to AB. This line perpendicular bisect the ABC. This line perpendicular bisect the AC. So we know, I mean, if we from the center, right? If from the circle the center we draw a perpendicular line, then it will bisect this segment. So that's why this line should pass in the center, this line should pass in the center, and this line should pass in the center. Okay, so the very important thing is you can see all this extension can pass in the center O. Then let's parameterize this as x and y and z, right? So we know the radius is 8, right? So it is 8 minus x, 8 minus y, and 8 minus z, right? So you can see we can cut this the hexagon, okay? We can cut this hexagon into 2 parts, okay? So the first part is the triangle ABC, right? The second part is triangle the AEB plus the triangle, the BFC, plus the triangle of the ACD. Okay. So for triangle ABC, you cut this one into 3 pieces, right? So we can do is half of the A times the Y plus half of the B times the Z plus half of the C times the X, right? This one we can see is the half of the C times the 8 minus X, okay? This part plus half of the BFC is A times the 8 minus Y. Then plus half of the B times the 8 minus Z. Okay, so you can see when you group them together, right? When you sum them together, it's equal to half of the C times 8 plus half of the A times 8 plus half of the B times 8 is half of the A plus B plus C. 35 times 8 is 35 times 4. Okay, the next will be 3 sides of 3 sides of quadrilateral is 1 to 5. Okay, let's see 1 to 5 and X. Okay, so we know by the rule, right? We know the 1 plus 2 should greater than Y, right? And 5 plus Y should greater than X, right? So that means the 5 plus 1 plus 2 should greater than X, right? And it works for any 3 sides, right? So any means sum of any 3 sides greater than 4th side. Okay, so now let's see. Okay, so if X is less than 5, right? So we need the 1 plus 2 plus X need to be greater than 5, right? And so then X need to be greater than 2. Then X can be 3 and 4. The next is if X greater or equal than 5, right? So then we need the 1 plus 2 plus 5 is greater than X. So X should be less than 8. So S can be 5, 6, 7. Then the possible X is equal 3 plus 4 plus 5 plus 6 plus 7. Okay, so keep calculating. Is 7 is 14 plus 11 is equal to 25. 378. So in this diagram, we so in the diagram we have a chord. Okay, let me draw a big picture. So X, D, B, A, C, and E. Okay. So if the CE is equal to 12, and AE equals to 8, and AB is 14. So AB is 14 means this one is 6, and AD is 10, okay? So we know we have the triangle, right? So you can see this angle equal this angle equal this angle, right? So we know the triangle ADE similar to triangle BEC, right? Okay, so before we do that, we use the power point of the E, right? So power point of the E tells us the BE times the EA is equal to the CE times the ED. So we can solve the ED, right? So it's 6 times 8 equal to 12 times the ED. Then it's 48. So ED equals 4. So ED equals 4, right? Okay, and then we have the triangle ADE is similar to this, right? So now we know that it's a 3 to 2, right? So the BC is 3 to 2 times the AD is equal to 15. Okay, so we solve this side equals to 15, right? Then we want to solve the AX, right? Okay, so if we want to solve the AX, now let's see, do we have some other similarities? Okay, so the AX is equal to AD plus XD, right? So in order to see the XD, we have we have a similar triangle of this, right? So we know the AXC similar to triangle the BXD, right? So now let's see whether we can borrow this. Okay, so first we see the triangle DEB is similar to triangle AEC. So that means the ratio of this one is 4/8. That means equal to this ratio means if this is the m, then this is the 2m. Okay, and now we know this triangle, right? Over this triangle, the ratio is 2, right? So if this ratio is 2, so we know the XD is corresponding to the sides. The XD corresponding to the sides of the XC, right? XC. Okay, so let's see if this is the if this is the P and this is the Q, right? So we know the P plus P, we know the 2P is equal to 15 plus Q, right? Also we know the 2Q is the Q is corresponding to size of the AX, right? Is 10 plus P. Okay, now we have an equation of the P and the Q, right? Now you can try to solve the equation. Okay, let's do it here. It's 2P minus Q is 15, and negative P plus 2Q is 10. So we can times 2 here plus together is 3P equals times 2 is 30 is 40, right? So we know P is 40 over 3. Okay. Now if the P is 40 over 3, you can solve the AX, right? AX is P plus 10 is 40 over 3 plus 10. Okay. So next problem is the 6 edges of a tetrahedron are measured at the 7 13, 18, 7, 13, 18, 27, 36. Okay, let's draw a tetrahedron of the ABCD. Okay, ABCD. So we know the AB is 41, right? So in order to make a triangle, we know the two sides add together should be greater than the third side, right? So let's see the combination of how many ways we can do more than 41, right? So 41, 13 plus 18 is only 31, right? So no way. So in order to make the 27 to be greater than 41, the 27 can only add 13 doesn't work, right? Add 18. If 27 group with the 36, then you never can have another one, have another 41, right? So 27 must be separate. 27 must be separate with from 36. Okay. Okay, so 27 can only group with 18, right? Then the 36 can be either group with the 7, right? Or the 36 can group with 13, right? Okay. So now let's see. I mean, because if we want to put 27 or 36 on the bottom on this side, right? So 27, 46, and then we put small number here, and this number here might be small, right? So that's why let's try to put the 27 here. Let's put the 36 here, okay? So 27 must be together with the 18, right? So 36 can be with the 7 or 13, right? So this one could be 7 or 13. Okay, so if this is 7, okay, so if this is the 13, right? And then this will be 7, right? So then 7 plus 27 is less than 36. Okay, so this one cannot be 7. So this one must be 7, right? And this one is 13. So this plus this greater than this, right? And this plus this greater than 41. This plus this greater than 41. 13 plus 7 is greater than 18, so this one work. So in this case, CD equals 13. Okay, we do some logic reasoning here. So a hexagon is inscribed of a circle with a radius of r. Okay, so we have a hexagon. Then two sides are 7 units and the other 4 sides are 20, okay? So let's draw some 20 units and the two sides are 7. Let's draw a 7. Let's draw multiple of the 20. Draw a small of the 7. Okay, let's just draw this. A, B, C, D, E, F. Let's see, this is 7 and all the rest of 20. Then we have the connected with the center, then we know everyone is R, right? So let's see, this is the beta, this is the beta, right? The chord is the same, so the centric angle is the same, right? Alpha, 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 alpha. Then we know the 4 alpha plus the 2 beta is equal to 360. We know the alpha plus the beta over 2 is equals to 90, right? Now let's set up equation, okay? So if we draw a line here, we know 20 is equal to the 2r and the sine of the alpha over 2. So we know 10 equals r times the sine alpha over 2, right? And the other one, we know the 7 is equal to 2r sine beta over 2. So we know 7 over 2 is r times sine of the beta over 2. Okay. And we also know this, right? We also know the alpha is 90 minus the half beta, right? So we know the 7 over 2 is equal to the r times the cosine alpha, and the 10 is equal to r times the sine alpha over 2. Okay. So now let's find the r, and if once we solve the alpha, we can solve the r, right? So now let's see, and the 7 over 20, this one over this one, right, is equal to the cosine alpha is 1 minus 2 sine square alpha over 2 over sine alpha over 2, right? So now you can solve equation as 7, set this one as x. So 7x is equal to 20, 1 minus 2x squared. So you can have the 40x squared plus the 7x minus the 20 equals 0. Okay, so what is the next step? The next step is to solve this equation, right? Let's divide by the 40. Okay, so it's let me see, there any, can I do the 20, 10 is 5, 8, 4 and 5. Okay, so we can do 5, 8, 4 and 5, then it's the positive, so this one. Okay, so we can do the 5x plus 4, then 8x minus 5 equals 0. So that's this one. Yes, 36. Okay, so that means x is positive number, right? So we can only take x equals to 5 over 8. Yeah, so now if we know the sine, so x equal to sine alpha over 2, right? So now we know 10 equals r times 5 over 8. Then we can solve the r equals 80 over 5 is 1 over is 16. Okay. Okay, so in the diagram, okay, we have the semicircle centered at P and Q. Okay. Let's draw a big picture. Okay, so we have the semicircle, this is center, so the P is, the circle P is larger, right? The circle Q is small. Then we have the circle of the P and the Q. Then we have a tangent line, tangent to both, right? The tangent point. so the radii of the P and Q are 10, right? So we know this is the 6 and this is the 4. Now this is the 4, this is the 6, right? 6 and 4, we know the middle is 10. So the diameter of the big semicircle is 20, right? Okay, so now let's see we want to find the tangent line, the length of the LM, okay? So in order to find the LM, okay, we normally, how do we calculate any chord length? Okay, if this is the O, and if we know the R, right, and if we know the distance between the point to the chord is X, then we can solve half of this is R squared minus X squared. Okay, so in order to do this, right, let's see, this is the center of the big semicircle is O. Okay, so we know this is 10, right? So this must be 4, and this must be 2. This is 2, this is 2, right? So we have the 4 plus 6. I'm sorry, this is 4, this is 4. So we have the 4 plus 6 is 10, 2, 4, 4 is also 10, right? Then we can land on here. So you can see that this point N is the midpoint of LM, right? And we know the radius is 10, right? So as long as we solve the ON, we solve it, right? And you can see we have a shape of the P for AB. Okay, PA QB ON. Right? This is 90 degree, 90 degree, 90 degrees. So they are all parallel. Okay? So this is the trapezoid. And we know the ratio, right? So the NB is 2 plus 4 is 6. This one is 4, right? So now we know the ON is equal to, the ratio is 4 plus A6 is 10, right? So it's 6 over 10 times the AP plus 4 over 10 plus times the BQ. So this one is equal to 3 over 5 times AP is 6 plus the 2 over 5 times BQ is 4. Okay, so this one equals 18 plus the 8 is 26. We solve the ON, right? And we know this is 10, right? Now we can solve the LN is equal to the 10 square minus the 26 over 5 of the square. Okay, then you can solve the LM is equal to 2 times LN. Then finally what you can get is finally what you can get is the 8 over 5, then it's 6 times 19. Okay, so yeah, it's about the first section of the problem for chapter 20. Okay, thank you.